Hi, BC students. So I am just running through the exit ticket today. So the first question is, it's a related rates problem. It says the equation below represents the surface area S of a sphere where R is the radius. Okay, so this tells us, this will give us the surface area of a sphere. And it says use the table of values below, the table is here, to determine the rate at which the surface area is changing at t equals 3 seconds. Okay, so cool. I'm going to switch up the values really quick. So let's say this is going to be 50 pi meters squared, and this is going to be -1 meter per second. So what do I know in this case? I already know that dr over dt is equal to -1 meters per second. I know S is equal to 50 pi meters squared. So the surface area is at 50 pi meters squared. I know t is equal to 3. And I think that's about it, right? So what do I still want to find, I guess, is the next main question. So use the table of values below to determine the rate at which the surface area is changing. So I want to find the rate at which S is changing. So I want to find ds over dt. This is my big question mark that I want to find. Okay, so let's just try to find ds over dt now. They give us the equation we want to use, right? So let's differentiate with respect to time. So if I d over dt of s, right, this will get us ds over dt is equal to d over dt of 4 pi r squared, right? So what is ds, sorry, what is the derivative of s with respect to t? Well, it's going to be 1, right, because it's just s, but then we have to multiply by ds over dt because we're implicitly differentiating, right? So it's going to be ds over dt. 1 times that is just ds over dt. So ds over dt is equal to d over dt of r squared. Well, I'm going to take out the 4 pi first, just to make it more obvious, but we're only differentiating the r squared. So that's going to be ds over dt is equal to 4 pi. Now I'm just going to do power rule, right? The derivative of r squared is 2r. Cool, but we're not done because we differentiated with respect to t, right? And we're differentiating r, so we need to multiply always, remember? Just always multiply by dr over dt in this case. Anytime you differentiate implicitly with respect to like a different variable, you always just multiply it by like dr over dt. So in this case, it's going to be equal to like 4 times 2, right? I'm going to get 8 pi r dr over dt. Cool. So let's just solve. I know I'm trying to solve for ds over dt, right? And that's equal to 8 pi r dr over dt. So I'm going to make that more obvious. ds over dt is equal to 8 pi r dr over dt. And that's going to equal to 8 pi r. Let's plug stuff in. dr over dt is -1, right? Meters per second. So it's -1. I'll just write -1. Okay, but I don't know r. So it seems like we're stuck, but let's just think about it. We want to find r. We're given s. So, oh wait, I could just plug that into here. So if I plug s in, I'm going to have 50 pi is equal to 4 pi r squared. So then I'm going to cancel out the pi's on both sides, divide by 4 from both sides. So it's going to be 50 over 4 is equal to r squared. So r is going to be equal to square root of 50 over 4, right? So I'm going to say equals 8 pi times r, which is the square root of 50 over 4, and then times -1, so -1. So honestly, you could kind of just leave your answer like this. So -8 square root of 50 over 4. If you want to figure out all the math, you can do that too to get like an actual number. But I'm fine with this. Okay, so the next problem is an optimization problem. So find two non-negative numbers, x and y, whose sum is 100 and corresponds to a maximum value of x squared times y. So what do we want to do? We have our constraint equation. This is the rule we have to follow. And we're told that we need to find two non-negative numbers, x and y, whose sum is 100. Okay, so we know x plus y must equal 100. Cool, that's our constraint equation. It must follow that rule. Next, we have our optimization equation. What do we want to either maximize or minimize, right? We want to optimize it. Well, we want to maximize here x squared times y. So we're going to want to maximize x squared y. So I just called the f just so I can really capture x squared times y and make it into an equation. Okay, so let's try to optimize it, right? So first, we want to get rid of one of the variables, right? Because we have x squared times y. Well, that's not very easy to optimize. How do I do like the whole minimums and maximums and then try to like find like the positives and negatives? That's really confusing with two variables. So let's just substitute in one of the variables for the other ones. So let's substitute in this y. Let's try to get rid of this y. Actually, also, I'm going to change this value instead of 100 to 25, just so I'm not giving you guys the exact answer, but same idea. So x squared times y. So x plus y is equal to 25, right? So y is equal to 25 minus x. Now this is going to go into here, right? Because that's y. So f is going to be equal to x squared times 25 minus x. Now we want to find f prime, right? We want to find f prime. I think it might be easier actually then to just distribute everything. So f is equal to 25x squared, right? I'm just multiplying the x squared out minus x cubed, right? So then I can find f prime to find all the critical points, right? That's why we're finding f prime, to try to maximize the value, right? We're trying to find the derivative so we can use the whole positive and negatives and find the maximums. So that's why we're finding f prime. So I'm going to do power rule, 25x squared minus x cubed. Well, I'm going to bring the 2 down, so it's going to be 50. X minus 3 down, so 3x, and subtract 1, 3x squared. So then I'm going to set this equal to 0. Let's factor out x. X times 50 minus 3x is equal to 0. Oh, okay, so this one's kind of interesting because it looks like we're going to have 2 points to test, whereas most of the maximum and minimum problems, we've only had 1 point. This time we actually have to test it. This time we actually have to test it because we don't know which one's the maximum and the minimum. So x can be either 0, right? Because when x is 0, the whole thing's equal to 0, or x can be equal to so 50 equal to 3x, x is equal to 50 over 3. Yeah, so x would have to be equal to 50 over 3. And that's because when I plug in 50 over 3 here, this whole thing turns into 0. So it fulfills the equation. I'll show what that looks like actually for 1 second. So if this is 0, right, that's going to mean that 50 minus 3x is equal to 0. So 50 is equal to 3x, right? I just moved the 3x to the other side. So x is equal to 50 over 3. So these are our two options. X is equal to 50 over 3 or 0. Well, let us find a number line. Actually, if we want to be smart about it, I realize there's another way we can do this. So, okay. So we're going to want to test each of these intervals. Well, I will say if you're smart about this, you're going to notice that testing this point is useless, right? So I'm trying to think. Actually, is it useless? No, I think it still makes sense. Never mind. Because if you plug in a negative number, I was going to say that we're finding two non-negative numbers, x and y, so it's useless to plug anything in there. But we're trying to find 0, like if it's going up to a maximum. So it's still useful. Like we know it's not going to be any one of these numbers. We know x can't be one of these numbers, right? But it's useful to find out if it's going up to a maximum. at these numbers. So let's plug in -1. So at -1, f prime is equal to 50 times -1 minus 3 times -1 squared. Right, so that's going to be equal to -50 minus 3. So it's a negative number. Okay. Well, it looks like this is going to be a minimum. Looks like 0 is going to be a minimum, right? So let's plug in 1 for this interval. So f prime is equal to 50 times 1 minus 3 times 1 squared is equal to 50 minus 3 times 1 squared, so minus 3. So that's going to be equal to 47. This one's equal to -53, sorry. Equal to 47, so that's going to be positive. Cool. Now let's plug in a number over here. Let's say 50 over 3 is what? I'm going to plug in 20. I'm going to plug in 20 because 20 is 60 over 3, right? So I know it's larger than 50 over 3. So f prime is equal to 50 times 20 minus 3 times 20 squared. That's going to be equal to 50 times 20 is like what? 1,000. 1,000 minus 3 times 20 squared is 400. So it's going to be 1,000 minus 1,200. Sorry. So that's equal to -1,200. So it's a negative here. Okay, cool. So I know I have a maximum here. That's a max because it's going positive. It's going positive, then negative, right? The slope is positive, then it's negative. So I know this is a max. Okay, so if I know it's a max, I can, I know I'm maximizing x squared y there. So I am going to now just find y, right? Because I know x is a max at 50 over 3. I'm going to plug in 50 over 3 into x plus y equals 25. So 50 over 3 plus y is equal to 25. Right, so y is equal to 25 minus 50 over 3. And I'm not going to do the exact math for that, although you can. So those are our two values for x and y. And that is it. So hopefully that made sense. And yeah,